Welcome to the first lesson of the year. This is Unit 1, Lesson 1 over solving systems using graphing, substitution, and elimination methods. Let's begin. Solving systems by graphing. First of all, we want to understand why am I going to choose this method? Why this one versus that one? Particularly for graphing, we want to be looking for equations that are already in y equals mx plus b form. You might be saying to yourself, y equals mx plus b form. I think one time my Algebra 1 teacher mentioned that to me. Yeah, they did, and it was pretty important. Y equals mx plus b form is known as slope-intercept form because we've got two little parts here that we're going to focus on, the m, which is the slope, and the b, which is the y-intercept. With those two pieces of information, we can graph any line. So, as we look in our system of equations, that second equation, y equals 2x minus 3, is in our y equals mx plus b form, so I can already graph this line. That's why we're going to choose to use the graphing method to solve this system. So, to graph a line, you begin by using the y-intercept, which in this case is -3. That means y-intercept, touch the y-axis at -3. Go down 3 spaces, put your first point. Slope. Slope can be thought of as the rise over the run. And rise just means how much we're going up and down. Run means how much we're going left and right. And really, we tend to think of slope as a fraction. 2 is not a fraction, so we're going to change it into a fraction just by making it 2 over 1. That gives me some directions to go now. So from my y-intercept, I'm going to generate more points by going up 2 over 1. And I just do this all the way like normal. You might run out of space, and of course you can use slope to go backwards, so instead of going up 2, right 1, I'm going to go down 2, left 1. And once I've got enough points, doesn't matter how many, you can just, as long as you have enough, draw your line. Okay, and we are halfway done at this point. Now we're going to use the second equation to do the exact same thing. However, the second equation, really it's the first equation, it's not in y equals mx plus b form. So we need to transform this to make it look like our slope-intercept form. And that means we're going to have to get the y here by itself. That means everything else on the same side as the y has got to go. The 3x and the 2. To begin, we're just going to move this 3x over to the other side here with the 8. And whenever you move something across the equal sign like that, you just change the sign. So the 3x comes over. Of course, the 2y stays put. We haven't touched that yet. But the 3x comes over. It becomes -3x. And that 8 is still on the right-hand side. That 8 is positive, so I'll write that +8 right there. Okay, halfway done with this one. Now we just need to get the 2 away from the y. We got to use the opposite operation to cancel the 2. And since the 2 is multiplying, we're going to divide everything by 2. That'll cancel the 2. Of course, now you can see the y is by itself, so I just need to clean up the right-hand side here, and then we'll have it ready to graph. Okay, -3 over 2, that fraction can't be simplified. We're going to leave it alone. Then the 8 over 2, that can be simplified. That's 4, so we rewrite this as y equals -3/2 x plus 4. Okay, it is now in y equals mx plus b form, so we graph it. Starting with the y-intercept, up 1, 2, 3, 4, and using the slope, go rise of -3 and run of 2 to the right. So from here, down 1, 2, 3, run 2. I'm going to keep doing that. Once you feel like you have enough points, then of course just graph it. That's probably good enough. Boom, that was an important point right there. Circle that right there. That's pretty darn important. That is the solution to the system of equations. In general, a solution is an ordered pair. And so that little intersection point, if we need to get that ordered pair and write that down, because that's what we were looking for. And ordered pairs, of course, go x, comma, y. So what is the x value of that ordered pair? Let's see, 1, 2. What is the y value? 1. And so that's our answer, 2, comma, 1. Okay? Moving on. Solving systems by substitution. Once again, we want to start by asking ourselves, why use substitution? Why use that one instead of any other method? Well, as I see here, the x does not have a coefficient in front of it. Again, coefficient means the big number in front of the variable. So like 5 is a coefficient, -2 is a coefficient, and so on. But 25 is not a coefficient. So because there is no coefficient in front of the x, or y, it really doesn't matter, but in this case x, then we're going to use substitution because it is easy to isolate x, to get it by itself. So we're going to take this second equation here, and we're going to get x by itself. And so I need to get rid of the 3y and the negative sign. Again, moving the 3y to the other side will just change the sign. I haven't touched the negative x, so I'll leave that alone. The 3y comes over, changing the sign to negative 3y, and of course I still have that minus 18 there. Okay, the x isn't isolated because it still has the negative sign. I just change the sign. That's all I have to do for something like that. So if I change the sign, I change all signs. This becomes positive, this becomes positive, and this becomes positive. Well, that's just x equals 3y plus 18. Now, why did we do all that? Because now I can substitute this whole part right here back into the x of the other equation. Okay, so that is what substitution is all about. You solve for an x or a y in one equation. You take that value and you plug that back into the x of the other equation. So let's do that here. We've got 5. Instead of x, we're going to replace that with 3y plus 18. And we need to write the rest of the equation. The minus 2y equals 25. Okay. Once again, the key, very, very important step here was we substituted the x, and in place of the x, we put this 3y plus 18, which we found in the beginning of this. Okay. Now I just have to clean this up a little bit using some basic algebra steps and solve for y. Step 1 here is going to be distribute. 5 times 3y is 15y. 5 times 18 is 90. And then minus 2y equals 25. Combine like terms. I see a 15y and a minus 2y. 15 minus 2 is 13. 13y plus 90 equals 25. Subtract the 90. 13y equals, let's see, how much is that? Negative 65, I think. Sounds about right. And then divide by 13. So then it's negative 65 divided by 13 is negative 5. And we are halfway done now. We figured out that the y value of the answer is negative 5. All I have to do is take that negative 5, plug it back into the y that I had originally, back over here, and I'll have my answer. So x equals 3 times negative 5 plus 18. 3 times negative 5 is negative 15. Negative 15 plus 18 is 3. So x equals 3. Taking the two values that I figured out, x is 3 and y is negative 5, I can say then that the answer is, just do this here, the answer is 3, 18. negative 5. Again, you always want to make sure you go x comma y. Alright, moving on. Solving systems by elimination. Now elimination, the main thing you want to look for, the ideal case, is that you have a pair of x's or pair of y's that have the opposite sign, and the best case would be if the numbers were the same, the coefficients were the same. And well, here I see 4x, and on the second equation I see negative 2x. While those aren't the same numbers, they do have opposite signs, which is very important, and it's very easy to multiply this second equation by 2 to make it match the 4x here. Let me explain that a little bit better here. So let's start by multiplying this whole equation by 2, and you'll see why here in a second. When I multiply every single part of this equation by 2, I'm going to have negative 4x minus, let's see, 2 times negative 5y is negative 10y equals negative 16. Okay, so, and that's completely allowed to do stuff like that. You can, as long as you do it to everything, then it's completely allowed. So I multiplied everything by 2, and that's what this value is over here, this whole equation over here. Let me rewrite that top equation again. I didn't change that one. You'll see why. Okay, the whole point in elimination is this. We see a 4x right here and a negative 4x right here. Well, if I have 4x positive and 4x negative and I combine them, they cancel each other out. And I have nothing, no x's at all. They are eliminated. That's the point. They are eliminated. So what we're going to do here is we're going to just combine these two equations together. We'll go down in a row and combine the x's, combine the y's, combine the constant numbers there at the end. The 4x combined with the negative 4x cancels each other out. There is no x anymore. The positive 9y combined with the negative 10y, well, I'm taking away more than I have. 9 minus 10 is negative 1y. Well, we don't need to write the 1, so we'll just say negative y. And 12 plus negative 16, or just 12 minus 16, is negative 4. And here all we have to do now is just get rid of this negative sign to solve for y. That just means change the sign so it's positive, change this sign so it's also positive. So there you go. The answer for at least y is that y equals 4. And just like in the substitution method, once you have found one variable, you plug that back into either equation and you solve for the original variable. In this case, that would be x. It doesn't matter which equation I pick. I just need to pick one of the, whichever one appears to be easier for me to do, and plug that in for y and solve it. So I'm going to go ahead and take that first equation, 4x plus 9y, but instead of y, we know that y is 4. So I'm going to replace the y with the 4. Okay, and I just have to clean this equation up and solve for x. 4 times 9 is 36, so 4x plus 36 equals 12. And we need to get x by itself, so I'm going to get rid of the 36 and get rid of that 4. To get rid of the 36, I'm going to subtract. And let's see here. I still have the 4x, but on the other side, 12 minus 36 is negative 24. And last step here, to get rid of the 4 is multiplying the x. To cancel multiply, you have to divide. So divide both sides by 4. Negative 24 divided by 4 is negative 6. And I've solved this system. I just have to write it as an ordered pair, because every single time the solution is an ordered pair. And so that would be negative 6, comma 4. And that's the solution.